Let's solve 217 contains duplicate. Given an integer array, we need to determine if any value appears at least twice. If so, we return true, otherwise we return false. Let's use this example over here, 1, 2, 3, 1. Since the value 1 appears 2 times, we should return true. I'll walk you through 3 different approaches to solve this. Approach 1, the brute force approach. This is the most intuitive approach, and it's about checking every possible pair of elements. For each element, we check if it's equal to any element that comes after it. If we find a match, we found a duplicate. So you can see we have 2 for loops, and we're taking every element using this for loop, and then we're checking every element that comes after it using this for loop. Okay, and if we see that 2 numbers are equal, we return true. The time complexity is O of n square because notice we have this nested for loop structure. The space complexity is O of 1 since we are not using any extra space that scales with the input size. Approach number 2, using sorting. After sorting the array which is given to us, duplicate elements will be adjacent to each other. Like for example, if these 2 numbers are equal, after sorting, these would be adjacent. We now just need to make one pass through the array and check if any adjacent elements are equal. The time complexity of this approach is O of n log n because we'll have to sort the array and then we'll just have to make one pass, which is an O of n operation. So the time complexity is O of n log n due to sorting, and the space complexity varies between O of log n and O of n if we take into account the space taken up by the sorting algorithm, but if we don't take that into account, the space complexity is O of 1. Approach 3, the HashSet approach. We'll just make one iteration through the array which is given to us, and for each element, we'll check whether we have seen it before by looking it up in our set. If it's already in the set, we have found a duplicate, otherwise we add it to the set. Okay, so you can see over here, if we have already seen it, we return true because we have found a duplicate, otherwise we're just adding it to the set over here. The time complexity of this approach is O of n because we're just making a single pass through the array, and the HashSet lookups are O of 1 on average. The space complexity of this approach is O of n in the worst case where all elements are distinct and we are adding things to the HashSet. Remember that space-time trade-offs are common in algorithm design. The HashSet solution uses more space but gives us linear time complexity, which is the preferred choice for this problem.